Hi friends, welcome back to SJ Wisdom. Hello friends, it's me Senna Jas. Today we are going to study the first lesson in chemistry, properties of matter. We know that substances exist in solid, liquid, and gaseous states. In this chapter, Properties of Matter, we shall study in detail the peculiarities of substances in the solid, liquid, and gaseous states. Can you see a picture? Okay, what are the objects seen in the picture? There are pencil, balloon filled with air, box, a glass of water, specs. What are the material present in each object? Balloon, solid. Water filled in glass, liquid. Pencil, solid. Specs, solid. Glass, solid. Box, solid. So, there are many objects of diverse nature around us. All these are made up of different materials. We are familiar with physical states of material. Which are the different physical states of material seen around us? It is solid, liquid, and gas. Now let's do an experiment. Procedure. Take two beakers which filled with same amount of water and dip the stone into them. What happened to the water level when the stone is dipped in the water? What is the reason? Rising the water level because when we dip a stone in the water, the stone which requires some space to occupy, then the water which possesses equal volume of stone will be raised. Let's go through another experiment. Fill 3/4 of a trough with water. Keep a dry glass tumbler perpendicularly immersed in the water in the trough. What happened to the water level in the trough? Rising the water level, right? Does water enter the tumbler? No. What material does the tumbler already contain? What is it? Air. Is there a relationship between the volume of these materials and the difference in the water level? Yes, the tumbler filled with air, this air requires some space to exist. Then the water which possesses the equal volume of air will be raised. So in simple, we can say that air occupies space or air which requires space to occupy. Let's go through another experiment. Hang two balloons filled with air at the two ends of 30 cm long metal scale. Affix a piece of sellotape on one of the balloon with the help of a thread. Suspend the scale in a balanced position. Then press the balloon with a needle on the sellotape. Observation. The horizontal level of the scale will be loosed. The balloon with affix with sellotape will be shearing and this part of scale will be raised because when we put a hole on the balloon, air will be loosed. As a result, mass of balloon will be decreased. In this observation, we can understand that matter is anything that occupies space and has mass. We are familiar with materials in solid, liquid, and gaseous states. Properties of solid. Solid have definite shape and volume, which have high density and have no freedom of movement. Properties of liquid. It does not have definite shape, then it accepts the shape of the vessel which taken, but it possesses definite volume and freedom to move. Properties of gases. It does not have definite shape and volume. It can move freely than liquid. Matter is also found in states other than solid, liquid, and gas. The fourth state of matter is plasma. Matter is found in plasma state in the central part of sun and other stars. Plasma is a state of matter in which the particles exist in ionized state at very high temperature. The fifth and sixth states of matter are named Bose-Einstein condensate and fermionic condensate respectively. Another state of matter is superfluid state. All these states can be generated in laboratory and under special conditions. Tiny particles in matter. Let's do an experiment to understand this part better. Fill 3/4 of a beaker with water. Put 2 or 3 crystals of potassium permanganate into it and stir well. What happened to potassium permanganate crystals? It is dissolved in water. Now, can you see the crystal? No. Why the particles cannot be seen even though potassium permanganate is present in the solution? Each crystal of potassium permanganate is made up of cores of tiny particles. For example, put some sugar in water and stir. Are the sugar crystals visible? Cannot be seen because sugar is made up of large number of minute particles. Does this solution have sweetness of sugar? Yes, the presence of sugar particles having the properties of sugar that gives the sugar solution to its properties. In this experiment, we can understand that each substance is made of tiny particles which cannot be seen with naked eyes. These particles bear all the properties of substance. Arrangement of particles in different states of matter. Particles have a distance between them. Particles move continuously. Particles attract one another. Observe the figure. Is the arrangement of particles in solid, liquid, and gaseous states the same? No. In which of these states do particles remain very close to each other? In solid state, particles are closely packed. Therefore, it have definite shape and volume. But liquid state, distance between the molecules is more compared to that of solids. Therefore, it does not have definite shape, but it have definite volume. In gaseous state, distance between the molecules is very great compared to that of solids and liquids. As a result, it does not have definite shape and volume. In which of these states are the particles most distant apart? Gaseous state. Now, observe this figure. What are the changes happen to the following properties when heated is absorbed? Energy of particles increases, distance between the particles increases, attraction between the particles decreases, movement of particles increases. We convert solid into liquid and subsequently liquid into gas by supplying heat. Examine the given picture. Conversion of solid into liquid. The process of conversion of solid into liquid by absorbing heat is called liquefaction, melting or fusion. The constant temperature at which solid gets converted into liquid is called melting point. Example, melting point of ice is 0 degrees Celsius. Conversion of liquid into solid. The process of conversion of liquid into solid by giving out heat energy or by reducing temperature or by cooling is called freezing or solidification. The constant temperature at which liquid changes into solid is called freezing point. The numerical value of melting point of freezing is same. Number 3. Conversion of liquid into gaseous state or vapor state. The process of conversion of liquid into its vapor at a constant temperature is called as boiling or evaporation. The process of conversion of liquid into its vapor at any temperature is called evaporation. The process of evaporation takes place much below boiling point. The constant temperature at which liquid gets converted into vapor is called boiling point. Conversion of gaseous state or vapor into liquid. The process by which gaseous state or vapor changes into liquid state on cooling is called condensation. 5. Direct conversion of solid into vapor state. Certain solid on heating or without heating directly changes into their vapor state without passing through the liquid state. This process is called the process of sublimation. Example: dry ice, naphthalene balls. Diffusion of substances in different states. Let's go through some experiments to understand this part better. Iodine is a substance that is easily converted into gas on heating. Heat a few crystals of iodine in a glass vase. Collect the vapor in a glass jar. Keep another glass jar on the top of it in inverted position. Observe the color of vapor. The color of vapor is violet. What change occurs in the color of iodine vapor in the lower glass jar? Fading the color of iodine vapor. What about the upper glass jar? The color is more denser. What is the reason for this? If iodine in solid state changes into gaseous state, the freedom of movement will increase. As a result, the number of iodine particles in the top of the jar will increase and it makes more denser color. An incense stick has fragrance, but the fragrance fills the room only when stick is tilted. Why do the fragrance spread quickly in the room when incense stick is lit? It spread to the other parts of room. Since the room is closed and air inside room does not go out, the molecules of agarbatti fill in the empty space between the molecule of air. Due to intermixing of the molecules, the fragrance spread throughout the room. The ability of gas to spread like this is known as diffusion. Is there any relationship between temperature and diffusion? Why does the smell of hot food spread quickly to a long distance? Yes, when heat increases, the freedom of movement of particles is also increasing. Then this particle can easily diffuse in air. Is the rate of diffusion of substances in gas and liquid the same? No. Gases can diffuse more effectively than solids and liquids. In this observation, we can understand that diffusion is the spontaneous mixing of different particles having freedom of movement. You can find more examples of diffusion from your daily life. Pure substance and mixtures. Now we are familiar with the states of matter and the properties of particles in these states. Each of the substances that we use are made up of tiny particles. Depending on their nature, substances can be classified into two: pure substances and mixtures. Molecules of water, common salt, and gold have their own unique properties. Materials made up of particles of identical nature are called pure substances. In saline water, both particles with properties of salt and water are present. The substances made of particles of different nature are called mixture. Separating the components of mixture. The choice of method of separation of component depends on the properties of components of a mixture. You know that salt is separated from seawater by evaporation. Is this method sufficient if water is also to be obtained through separation? Here we use distillation. Distillation. When one component of the mixture is volatile and the others do not vaporize under the same condition, they can be separated by distillation. If the components of a mixture possess a large difference in their boiling point, they can also be separated by distillation. Fractional distillation. If the boiling points of the component have very small differences, fractional distillation is to be used to separate them. Or in another word, we can say, if there are more than 2 components in the mixture, they can be also separated on the basis of increasing order of their boiling points. This method is called fractional distillation. Read this. Separating using separating funnel. Activity. Fill 1/4 of a bottle with kerosene. Pour equal amount of water into it. Close the bottle and shake well. Keep it aside for a few minutes and observe. What do you observe? It forms 2 layers. Water being heavier forms the lower layer is separating funnel, whereas kerosene being lighter forms the upper layer. What is the reason? Because the denser liquid forms lower layer and lighter liquid forms upper layer. In this mixture, water is more denser than kerosene, so it forms lower layer and the other forms the upper layer. Separating funnel is an opaque structure used for separating immiscible liquids from their mixture. Look at the picture showing the separation of liquid mixture with the help of separating funnel. Sublimation. The process in which a solid, when heated, changes directly into gas without melting into liquid is called sublimation. This method can be used to separate the components which have the property of sublimation from the mixture. Centrifugation. This is a method for separating components from a mixture based on the differences in the mass of particles. In order to separate insoluble particles in liquid mixture on the basis of their mass difference, centrifugation is used. This process is known as centrifugation. Chromatography. Put a black spot using a sketch pen on one end of a filter paper cut like a ribbon. Keep this dipped in water in a beaker as shown in the figure. Chromatography is a method used to separate more than one solute dissolved in the same solvent. This method was first employed for separating colored substances, and hence this process came to be known as chromatography. Okay, this chapter is over. I will give the answers of the question and answer behind the chapter in the description box. This chapter is over. See you next time with another chapter. Thank you and have a nice day. Bye.